Hello folks, welcome to the Forensic Post TFP. Today we are going to learn about photogrammetry. So, what is photogrammetry? How was it invented? What's its relevance in forensic science? How can one get started with photogrammetry? If you want to know more about this, kindly stay tuned. A bit of history. Photogrammetry was invented in 1851 by Lauseda and has continued to develop over the last years. The technique can be traced back to 1480 with Leonardo da Vinci's research on perspective. Efforts in photogrammetry have increased tremendously recently due to the availability of digital cameras, satellite imagery, scanners, increased computing power, and image processing tools. So even though the technique dates back as early as 1480 with da Vinci's research on perspective, it was in 1851 that the French inventor Émile Lauseda saw the possibility of using this newly invented camera in mapping, which gave rise or paved the way for photogrammetry. In 1851, Émile Lauseda was a French scientist, a surveyor, as well as a photogrammetrist. Starting with the introduction, when we say photogrammetry, it is basically a three-dimensional coordinate measuring technique that uses photographs as the fundamental medium for measurement. Photogrammetry helps in reconstruction, especially in forensic science when we are looking at a scene or an evidence. So it gives us a 3D model or a view by stitching 2D images together. So basically what we are saying is that in forensic science, photogrammetry can provide a 3D model of a crime scene or an evidence, which is useful or helpful in crime scene reconstruction. Photogrammetry is the art, science, and technology of obtaining reliable information about physical objects and their environment through the process of recording, measuring, interpreting photographic images, and interpreting photographic images. Photogrammetry utilizes information between overlapping images. This aids in the 3D model generation process. So when doing photogrammetry and you are taking photographs, you have to make sure that the images do overlap. So it is these overlapping images or the portion of overlap that is going to help in the 3D geometry creation process that would result or build up our 3D models. So when we're looking at the types of photography, you can group them or classify them into two, depending on the lens settings or the lenses settings. We can have a far range photogrammetry and we can have a close range photogrammetry. And the other one can also be in terms of aerial photogrammetry and terrestrial photogrammetry. From the names, it is self-explanatory based on either it is going to be on the lens settings or on the aerial or from the terrestrial view. An important part, the process of acquiring photogrammetric data or doing photogrammetry. First of all, we need to capture good quality images. And to capture good quality images, you need a good image capturing device. So here it could be any image capturing device. The next thing we do is to fuse the images, and we can only fuse the images by virtue of a 3D model creation software, which is a photogrammetry software. So here we need the software to do the fusion or the joining of the images, the 2D images, to create the 3D model. Then now, after the 3D model is being created in the photogrammetry software, we need to obtain data for evaluation and interpretation. So the tools that can be used, that is the image capturing device, are so vast. Any good quality imaging capturing device at your disposal can be used for photogrammetry. You can have DSLR, you can have smartphones, GoPros, 360-degree cameras, etc. All can be used for photogrammetry. Now talking about software, There are numerous software available with different payment options or plans. You can have access some of them for free versions, and you can also have some of them for open source. So you choose what's suitable for you and your work. Some examples of photogrammetry software includes, or some photogrammetry software in the market. The popular ones are 3D, F-Zipher, Metashape, Allison Vision Mushroom, Photo Modeler Technologies, Reality Capture, Regard 3D, etc. There are so many there at your disposal. So in the image here, if you observe the image clearly, we have so many windows open. But if you look at the main part, that is the mid canvas or the mid portion of the interface, we can have a building with so many blue indicating what camera positions and angles. And just below that, you can see like the individual images that were being captured and were being used to generate the 3D image through the photogrammetry software. So it is that easy and simple. Photogrammetry versus 3D scanner. Both the photogrammetry technique and the 3D scanning method all produce 3D models. The 3D scanner is faster and easier in obtaining and processing images. But the challenge with 3D scanners is that they are very expensive. Not everyone can acquire or have access to 3D scanners as compared to photogrammetry. Photogrammetry is a far cheaper method and can also produce accurate and reliable methods. Now let's look at the forensic applications of photogrammetry. Photogrammetry can be used in a broad range of practical forensic applications, including crash measurement on damaged vehicle, skid mark measurement, bullet trajectory. You can use that one to do your bullet trajectory, ballistics, shoe and tire print scanning, glass pattern measurement, DPA, suspect hide recovery, accident and crime scene mapping and diagramming. So all these things are just general things that can be done with a 3D scanning software, but photogrammetry can also be used to provide accurate data of all of these applications or these situations. Now let's look at some advantages of photogrammetry. So comparing photogrammetry and a 2D photograph, photogrammetry is more accurate, or it gives more accurate measurement as compared to what our conventional 2D photographs. And we can have ease of access to equipment. Comparing photogrammetry to what a 3D scanner, it is easier to acquire or access photogrammetry. The tools are easy to obtain. Almost anyone can acquire a good image capturing device and can also have access to photogrammetry software. And it does not require a lot of training to understand or to do photogrammetry models as compared to using a 3D scanner. Now, some limitations that I would like to raise for now is when working with photogrammetry, because you have to capture the images and later process them in a software, there is no real-time monitoring. Let's say when you're using a 3D scanner, you can be scanning and be observing your models whilst you are going through the scene, but with photogrammetry is a bit limited in that direction. And because of that, that gives us our next point. There is a tendency to get incomplete model when you miss certain portions of an image or not captured well. So when certain portions of an image is missed or not captured very well, you may not realize until you process them on the software. Then you realize that some portions of the models or your 3D data is missing, and you may have to return to the scene to capture if the scene is still undisturbed or it's still possible for you to get back there. So this is a limitation, I think. To conclude, photogrammetry can also be thought of as the sciences of geometry, mathematics, physics that use the image of 3D scene on a 2D piece of paper to reconstruct a reliable and accurate model of the original 3D scene. Photogrammetry can be a very valuable part of forensic toolkit. For an investigator or reconstructionist, it can provide better information about an accident or crime scene. For a lawyer, the presentation of concrete visual reconstruction can have a powerful effect on a jury. When applied correctly, photogrammetric analysis can make the critical difference that solves a criminal investigation or wins an